Chapter 2, chapter 2, motion in one dimension. Motion in one dimension. So we start with this chapter with this example. Pay attention with me, because this example we are going to do most of the illustration. Let me enlarge it a little. So this example, look, at the bottom, there is the x-axis at the bottom. Here is the origin at 0. And here is our car. It will move from A to B, and then to C, to D, to E, to F. So it will go forward, and then it will go backward. And then it will go backward. طيب. هلا let's try to understand these data. So position A at time is equal 0, the distance is 30. So at times equal 0, that means here. The car was here. زي ما انتم شايفين, the car is here. طيب. B, after 10 seconds, the car is 52. So 52. So here in the example, he's following the car, the door handle of the car. So that's 52. That's 52. After another 10 seconds, the car went into C. So C, the car handle, it's here. It's 38. After another 10 seconds, so 30 seconds, the car returned back to 0. After another 10 seconds, the car now is at minus 37. And after 50 seconds, the car is minus 53. Okay? Any question about the motion of the car? Because after that, we will just spend a lot of time analyzing this motion. So the car goes from right to left, and then go backward from left to right, sorry, and then it will go from right to left.
So now what we can understand that the car has moved from right to left and from left to right.
From left to right, and then from right to left.
Yeah, so that's what we get understand.
Yes, A to B, that's left to right, and then B to F.
Okay.
زينون؟
زينون.
طيب خلينا نشوف الحين this graph. So this is time, and this is X. So we started at 30. So this is 30. And time is equal 0. Then after 10 seconds, we went to 52. That is 52. And then after 20 seconds, we went back into 38. That is 38. After 30 seconds, we went back to 0. After 40 seconds, we went back into minus 37, this one. And finally, this point, minus 53. That's the motion. Okay? Now let's start to see. Okay, first of all, let's talk about displacement. Displacement. And when we say displacement, that is a vector. يعني it has a magnitude and a direction. لاحظوا, please notice that all our motion, left to right or right to left, always happen in one dimension. Always happen in one dimension. And indeed, the title of the course is motion in one dimension. Because it's motion in one dimension, if the displacement, or if the number has a positive and negative, that means it's displacement. That means it's a vector. It's a vector. If does not have a sign, that means it's just a distance. So the first thing, displacement and distance. Displacement is a vector. Distance is a magnitude, scalar. Distance is a scalar, just a number. Displacement is a number with a direction, with a positive sign or negative sign. So for example, بالعربي إزاحة، إزاحة ومسافة، إزاحة ومسافة. هلا for example الماس it's a scalar. What's your mass? 50 kilogram, 60 kilogram, 70 kilogram. You will never say 70 kilogram to the left or 70 kilogram to the right. So distance is just a number. 5 meter, 6 meter, 7 meter, 10 meter. Displacement is a number with a direction. Positive 10, that means from the origin, it's left to right, you go to the right. Negative 10, from the origin, you go to left. So that's the difference between displacement and distance. Distance is just positive. It's just positive. Displacement of a particle, change in position in a given time interval. So it is defined as x final minus x initial. Here, for example, we will just answer this question about what's the difference between displacement and distance. Suppose that there is a basketball player standing here. And he goes to the other side and then come back to his original position. And what's the distance of the basketball? Let's say it's 30 meters. Let's say, I don't know what's the distance, but let's assume it's a 30 meter. So now, what's the distance covered by the basketball? It's 60 meter. Correct. طيب. What's the displacement of the basketball player? The displacement is 0. Displacement is 0. Distance, 60. 30 plus 30, 60 meter. But displacement is 0. Why? Because displacement, we use vectors. He went minus 30 meter and then plus 30 meter, so that's a 0.
دكتور
نعم.
بالنسبة للإزاحة أنت بتحسب يعني المكان الأول والمكان الأخير.
المكان الأول والأخير as a vectors، يعني معاهم إشارة.
أيوة.
معاهم إشارة.
30.
بينما ال distance I just add the distances. طيب. Now let's try to analyze the graph that we started with. لاحظوا. What is the average velocity? The average velocity. الحين انتبهوا لل convention of the book. Pay attention for the convention of the book. When he write the symbol like this, that means this, he means velocity. Okay? when he's talking about speed, this is how he writes speed. That is speed. So pay attention for the convention. This is speed and this is velocity. This is the convention of the book. Other books just use the vector sign, but in our book, this is how he used the convention to write velocity. طيب, what is velocity? Average. It's delta x over delta t. Delta x over delta t. Well, what is delta x over delta t in mathematics? It's the slope, as Ubaida said. It's just the slope. هلا, again, pay attention, إنه the average velocity here is just a straight line. But the actual motion is not a straight line. So here we are talking about the average velocity, the average motion, not the instantaneous velocity. We do not know what happened between A and B. But on average, we can determine what happened between A and B by finding the slope. Finding the slope. And as your smart friend Ubaida wrote, it's the derivative. Well, the slope is nothing but the derivative, or the derivative is nothing but the slope. The derivative is nothing but the slope. Okay, so we mentioned 2 points. The velocity average is delta x over delta t, which is the slope or the derivative of the equation. However, the instantaneous velocity is not known. لأنه I don't know what happened between A and B. This is a dummy presentation for the graph. يعني it's not exact. We know the value of A and the value of B, but in between we don't know. So we can find the average, but we can't find the instantaneous. Clear? Any question? Move on. طيب, let's take an example, a numerical example. Here, delta x over delta t. Delta x, by definition, is x final minus x initial. X final minus x initial. Or delta t, t final minus t initial. So x final is this point. طيب, what is this point in the x-axis? We just know this point. It's 52. And what is this point? It's 30. So 52 minus 30 divided by 10 minus 0, it's 2.2. 2.2. لاحظوا, and it's very important, this is vector. This is a vector in one dimension. In one dimension. Because it's positive, معناته it's to the right of the origin. To the right of the origin. If it was negative, that means it's to the left of the origin. Clear? Because we are talking about average velocity. Well, let me tell you this. For significant figures, Yaman asked, we have to keep in mind the number of significant figures as well? No. For significant figures, you need to apply the rules for significant figures if it is stated in the question clearly. Like I will tell you in the question, consider significant figures. Consider significant figures. Or I'll tell you, apply significant figures. If I don't tell you apply significant figures or consider significant figures, then we use the rule of the book. The rule of the book. The rule of the book, usually he uses one number or two numbers after the digit. Is that clear? لأنه لاحظوا, if you need to apply the significant figures here, what's 52 minus 30? It should be 52 minus 30. Now here, this is one significant digit. And this is two significant digits. In addition or subtraction, always we go for the bigger significant digit. That means, let me explain it. So this is tens. This is tens. This is tens and ones. Significant digits, we have to use tens. So strictly speaking, 52 minus 30, when you apply significant digits, it's 20. It's 20. So 20 divided by 10, that is 2. But here, he is not applying significant digits. So let me repeat. If I ask you specifically in the question, respect significant figures or apply significant figures, then you need to respect and apply. Other than that, we just use the convention of the book. The convention of the book, after the decimal, sometimes he keep one digit, sometimes he keep two digits.
دكتور بالنسبة للزائد والناقص مش احنا بنحسب بس بعد الديسيمال؟
زائد وناقص انت بتحسب بعد الديسيمال if you have a decimal, but if you don't have a decimal, you apply, always you go for the bigger one. هلا احنا ليش عملنا الديسيمال؟ يعني مثلا when you say 1.1 minus 0.01, why we consider the smallest decimal? Because this accuracy is 1 over 100, and this accuracy is 1 over 10, so then we go for the 1 over 10. So again, if you use 1 minus 0.1, okay, also the result is 1. Why? Because this is 1 over 10 and this is ones. So we consider the 1. If you go for 10 minus 1, the answer is 10. Applying significant figures. That's for addition and subtraction. So, in the problem, if I ask you, consider significant figures or respect significant figures, apply significant figures, then you apply them. Other than that, you just use the convention of the book. Yeah, it's one significant digit, but...
ليه 10 minus 1 equal 10؟
شو؟ What's the question?
مش المفروض 10 minus 1 يديك 9 عادي؟ ما هو لسه one significant figure.
بس الاديشن والسبتراكشن it's a different rule. addition والسبتراكشن you go for number of decimals يعني او ones with ones it's okay normal. Tens with ones you neglect the one. If it is less than 5 it's a 0. If it is more than 5 that's a 10.
Yeah, so 10 has 0 decimal places, 1 has 0 decimal places, and 9 has 0 decimal places. So
0
10
decimal
minus 1 equals
places?
9.
What do you mean 0?
No decimal places.
ما
so
هو
can subtract.
الديسيمال places يا brother, decimal places it's the indication for the bigger rule اللي هو when you add ones and tens you neglect the ones. When you add tens and hundreds you neglect the tens. When you add 200, 1,000 and 100 you neglect the 100. That's the rule. فهو he applied for the point or the decimal. Always you go for the smallest decimal يعني tens and ones. 1 على 100 1 على 10 you ignore the 1 على 100. You get the point?
الصراحة مش عارف.
ما هو طيب هلا
You said that with the
يا brother يلا what's the result? 0 1. What's the result? Apply the rule.
0.1.
What's the result? 0.1.
Yeah.
طيب be careful.
Because there is 1 decimal place.
Yeah, what's the rule?
So here there is 0 decimal places. 1.
Huh?
Answer is 1.
It's 1.
1.
طيب 1 minus 10.
That's 9.
That's 10.
I say it's 9. The answer is 10. But
Yeah, this is the rule.
Doctor, there is no decimal place. You said that in addition and subtraction, we get concerned with decimal places.
طيب
And here there is no
أستاذ
decimal place, so
أستاذ
the answer is 9.
أستاذ this is the rule صح؟ طيب هاي الرول من وين أجت؟ What's the source of that rule?
Lowest decimal place.
طيب ما هو طيب يا أستاذي يلا مش هذه ضرب 10 to the power 1 minus 0 point عفوا هاي to the power 10 to the power 1 وهذه 0.01 10 to the power 1 مظبوط ولا لا؟ مش هاي بتصير 1
اوكي
وهاي شو بتصير 0.1 صح؟ هلو
ايوه نفس الحاجه.
طيب نفسها طيب هيها 0.1 ضرب 10 to the power 2 minus 0.01 10 to the power 2 هاي شو بتصير؟ هاي بتصير 1 وهاي بتصير شو؟ بتصير 0.1 يعني هاي الرول هي نفسها it will apply انه لما يكون عندك آحاد وعشرات you ignore الآحاد. لما يكون عندك عشرات وميات you ignore العشرات. لما يكون عندك hundreds and thousands you ignore ال 100 etc etc. على كل حال مش هذا موضوعنا. موضوعنا our subject إنه if I ask you specifically in the problem to respect the significant digits, you apply the rules of significant digits. Other than that, you just apply the rule of the book اللي هو after the decimal one or two numbers. يعني you are not obliged to always use the significant digits in physics problems unless we specify that. We tell you respect the significant digits. طيب. We were talking about what? We were talking about average velocity. Average velocity. Now let's talk about average speed. Here is the example. Let me just enlarge it so you can read it. Example. It takes you 45 seconds to travel 100 meters down along a straight hallway in an airport. At 100-meter mark, you return 25 meters along the same hallway, taking 10 seconds to make your return trip. Clear?
Clear.
يعني 100 meter 45 seconds. And then 25 meter 10 seconds. Here is the question. Average speed, average velocity. This is, oh my God. This is velocity. Velocity. And this is speed. طيب, average velocity, you went 100 and then you came back 25. So what's the displacement? 75. 75. طيب, what's the total time? 45 plus 10. That's 55. So average velocity is 75 divided by 55. طيب, average speed, no. Total distance, 100 plus 25, that's 125 divided by 55. So average velocity is 1.36 in the positive direction. Average speed is 2.27 meter per second. Clear? No, I didn't say that. That's wrong. That's wrong. V average, we need to stick to the convention of the book. هلا V average ولا V X average, it's always talk about the velocity. It's talk about the velocity. I was mistaken when I said this is speed. Now, average speed, according to the convention of the book, it's just average speed. Correct? أحمد أنت صاحي معنا كويس, يعني good sign هذه أحمد. It's a good sign. طيب. الحين let's see this example. Find the displacement, average velocity, and average speed of the car in the figure between position A and position F. Between position A and position F. So this is the displacement. This is displacement. It's the final position, x final minus x initial. So the final position is minus 53 minus 30. So that's minus 83. Clear? دكتور, why 75? When 75 يا بني؟ فوق؟ 75 because 100 in this direction and then 25 in the opposite direction. Sorry. Yes? Okay. Clear? طيب. Now let's calculate the velocity, average velocity. Average velocity. Well, average velocity is equal average displacement, not average, displacement divided by time. So this is displacement and this is time. We said minus 83 over the total time, which is 50. It's minus 1.7 meter per second. It's a vector, so the magnitude of the velocity is 1.7 meter per second, and the direction of the velocity is it's from right to left. From right to left. Clear? يعني answer me, or you are drinking karak tea or busy with something يعني. Clear؟
دكتور
تفضل.
اكس اف واكس دول اللي هم
اكس اف اذا بتتذكر هذه اف واكس اف اللي حكينا عنها ايش؟ هاي البوزيشن. واكس اي اللي هو هذا البوزيشن. تتذكر اول شيء لما حكينا في المثال وحكينا we will spend some time here because all the example after that follow the initial understanding.
اوكي.
يوسف علي, I'm still thinking. إذا بدك يوسف, come to the office hour. We will discuss it in details. Come in the office hour and then we'll discuss it in details. طيب. Now let's do the average speed. We were talking about the average velocity. Now we talk about the average speed. For the average speed, we need to calculate the total distance traveled, not displacement. So let's calculate the distance. Between 52 and 30, he covered 22 meters. Between 52 and 38, he covers 14, or the car covers 14 meters. From 38 to 0, 38. From 0 to 37 is 37. And from minus 53 to minus 37, that's 16. Add them all, that's 127. Divide by 50, we get the average speed. And there is something wrong in the slides, because here he used, it's very confusing, here he used this V average as the average speed, while he used here the same symbol as the velocity. This is why I was confused. So there must be some mistake in the PowerPoint slides. So this is average speed, not average velocity. تفضل.
How about we use our own convention symbols? Like, let's say that velocity is v with a vector and speed is...
That's much easier, but يعني we need to
Like,
stick
we
to the
forget about the
convention.
book.
We need to stick to the convention of the book, because that's in other books very simple. this is velocity and this is speed.
Yeah, I
In
mean
other
in
books,
exams because we
yeah,
still don't know
this is
what we're
velocity,
considering. So
yeah, and this is speed. So that's a very easy convention. He is himself, he sometimes, like, he used the same symbol for velocity and speed.
so what do we have to do, us as a student?
Well, you can use this convention. You can use this convention. Everybody can use this convention. It's okay.
All right.
So this is a vector, and this is the magnitude of the vector. It's much easier. His convention is very confusing. I saw somebody was asked a question about, but here the speed, its convention is the same as the velocity. Yeah, we will just, we can differentiate by putting a vector. I don't know why he's mixing the convention of the book. Yeah, it's much easier to write v for speed and v with the vector for velocity. Okay. So far خلصت المحاضرة على فكرة. It's we'll stop here. We'll stop here. We continue inshallah Tuesday by the instantaneous velocity and speed. Let me stop the recording and see if you have any question.